The next rule to simplify our differentiation is the quotient rule. And similar to the product rule, if we have two functions, like for example this 3x minus 4 and the x squared plus 5, and they're being divided, we can use what's called the quotient rule to differentiate them. So that's what we're going to do here. The pattern looks a little bit complicated, but it's actually not that bad when we examine it. So it's basically saying the derivative of f over g, so if f and g are two functions, is f prime of g minus f g prime all over g squared. You might notice that this top part looks very similar to something else we just learned, which is the product rule, right? It looks very similar, except it's got a minus sign in between and a g squared on the bottom. So let's see how we can apply this quotient rule. So for this first problem, let's pretend this thing on the top is the f, and let's pretend the thing on the bottom is the g. So if that's the case, h prime of x is just going to equal, well, it's going to be f prime g minus f g prime all over g squared. And we could just sort of plug in what each of those things are now. So f prime is just the derivative of what's on top, which is just 3. And g is x squared plus 5 minus f, which is 3x minus 4. Oops, that's a 4. Times g prime, which is just 2x, all over g squared. X squared plus 5 squared. That's what h of x is, or h prime of x is. That's what the derivative of that function is. Again, we can expand, we can simplify, we can maybe see if anything cancels out of the top and the bottom, but really that's your answer. Okay? So not too bad. So looking at example B, we see that we have sort of two parts to this function here. And this part here looks like it could be applied to the quotient rule. And this part here looks like it's just a normal polynomial that we know how to find the derivative of. So again, when this happens, we can just take the derivative of those two parts separately. So y prime is going to equal the derivative of that first part, 2x over x plus 5. And this is where we're going to apply the quotient rule. So again, looking up top left corner, we see that the quotient rule is up there. So f prime is the derivative of the top, which in this case is just 2, times g, which is x plus 5, minus fg prime, so 2x, and g prime is just going to be 1, right? Then we divide that by g squared, and g is just the thing in the bottom, so x plus 5 squared. And then remember we have that second part, minus, and then what's the derivative of 2x squared? Just bring that 2 down, 4x. There's our derivative. Again, we could simplify, maybe make it look a little bit nicer, but I'll leave that part up to you. Okay, so now we have example 2. It's asking us which points on the graph of 5x over x plus 2 is the slope of the tangent equal to 2/5. So obviously the first thing we need to do is find the derivative of that function. So let's do that. I'm just going to do it right underneath. So f prime of x equals, and if you remember our pattern, we'll call the thing in the top f, the thing in the bottom g. It's going to be the derivative of the top, so 5 times x plus 2 minus 5x times the derivative of the bottom, which is just 1, all over x plus 2 squared. So that's the derivative. We just found the derivative. Now the question is asking us, if we go back to that question, where the slope of the tangent is equal to 2/5, right? So what do we have to do? Well, we're going to have to plug in that 2/5 as f prime of x, right? And then solve for x. So essentially 2/5 is going to equal this. And this is a case where you actually do have to expand and simplify in order to solve, because it's going to end up being an equation we have to solve, right? So we end up with 5x plus 10 minus 5x all over x plus 2 squared. And that's going to come out to x squared plus 4x plus 4. You'll notice that this 5x and this 5x are going to cancel each other out. So we end up with 10 over x squared plus 4x plus 4 equals 2/5. This is another good point. Oops, that should be a 4 there at the end. This is another good point. If you want to pause it and try to solve this equation yourself, you can do that, and then I'll show you the answer. So if you do the math, you get a quadratic, which you can end up factoring, and the answer is, it tells us that the slope is equal to 2/5 when x equals -7 or when x equals 3. So 2 points. And that makes sense because we're looking at basically a rational function here, which is a little bit complicated. So it makes sense that there might be 2 points where the slope is equal to 2/5. Again, if you're ever confused by this, throw the function into Desmos and you can see what the graph of the function looks like and those 2 points. So here we have one more problem where we're trying to find where the tangent of 2x plus 8 over root x, where the tangent of that is horizontal. So again, really what that means is we're looking for where the derivative equals 0. So let's try this question. Just going to zoom in here. So f prime of x, we can just apply the quotient rule again, right? Because this is really like a function divided by another function. So to apply the quotient rule, we're going to take the derivative of what's in the top, which is just 2, and we're going to multiply it by what's in the denominator, so just root x. And then we're going to subtract the what's in the top, so 2x plus 8, and multiply that by root x. And remember, just root x really just is x to the 1/2. So when we do the derivative of that, we're really just bringing down that 1/2, so it's going to be times 1/2 x, and then that exponent goes down by 1, so -1/2. And that's all going to be over root x squared. Now, root x squared is just x, right? So let's simplify this a little bit. We are going to have to do some algebra with it to find out where f prime of x is 0, so it's probably best if we simplify it a bit. So let's start off by simplifying that second part here. We have 2x plus 8. Basically, that's all over this 2 and then x to the 1/2. So it sort of looks like that, right? And this is all over x. Okay? We can simplify it further. I want to basically combine those two fractions in the numerator. But before I do that, actually I can simplify that a little bit more. Minus x plus 4. I can cancel out that 2, right? And I'm actually just going to make this root x again over x. I got to find a common denominator here. So the common denominator is just going to be root x. So basically I'm just multiplying this first function here by root x over root x, right? In order to make that work. So what that's going to look like, root x times root x is just x. So I'm going to end up with 2x minus x, and I'm going to distribute this minus sign to the 4 as well, minus 4, all over root x. And instead of writing divided by x at the end, I'm going to change this to a times 1 over x, just to make it a little bit simpler. And we can write the fully simplified thing, 2x minus x is just x minus 4 over x root x. So that's our derivative. Simplifies quite nicely to x minus 4 over x root x. So remember what we're trying to do though. We're trying to find where the tangent is horizontal. And to do that, we're looking for where the slope is horizontal, or the derivative is horizontal. And recall, this is just what this value equals. So 0 equals that, and now we have an equation to solve. When we do that, we don't really care about what's on the bottom because that just tells us that x can't equal 0. So we look at the top, which value of x is going to make this equal to 0? Obviously, the answer is x equals 4. So at x equals 4, the function will have a horizontal tangent. And it does, I think, in the question, asks us for the coordinate of the point. So if we plug in that 4, x equals 4, into f of x, we end up getting that f at 4 is just equal to 8. So therefore our point is 4, 8. And that's the final answer.